section, we're going to be talking about the least common multiple. Let's review our terms. A multiple of a number is the product of the whole number and any non-zero whole number. So we're going to take 6 for an example. The factors of 6 are finite. Let's list the factors of 6. We have 1, 2, 3, and 6. Now the multiples of 6 are going to be 6, 12, 18, 24. I'm going to put 3 dots after it, which means they continue on. The term finite means that it's a certain amount, no more, a certain amount. But the multiples, as you can see, continue to go on and on and on. There are an endless amount of multiples of 6. So, our lesson is we're trying to find a common multiple. It is a multiple that is shared by 2 or more numbers. So, I'm going to list the multiples of 4. I'm going to list the multiples of 6. So if you were to look to see what is the least common multiple, I'm going to circle 12. Another multiple that they have in common is a 24. But our goal is to find the least common multiple. The least one. So the least common multiple of 4 and 6 is going to be 12. Now, as you can quite remember from our lesson a couple of days ago, to find the greatest common factor, you can do the factor trees. If you can't tell by just looking at the numbers. Remember how we listed these, and if it's the greatest common factor, it had to be a factor in each one. So the greatest common factor of 4 and 6 is 2. Now, you're going to be instructed in some of your lessons to find the least common multiple of the numbers by listing the multiples. And it's just to show that you know what the multiples are. So let's list the multiples of 6 and 8. So the least common multiple of 6 and 8 is 24. And then I'm going to list the multiples of 9 and 10. I'm going to stop on this.
When it gets to 90?
When it gets to 90, because in your heads you know what the multiples are 10 are. But again, you will be asked to list them to show that you know what they are. So the least common multiple of 9 and 10 is 90. So we've discussed how there could be an error in just listing out the multiples. So now we're going to find another way of finding the least common multiple by using prime factorization. So let's do the prime factorization tree for 24 and for 30. And then we will list the prime factorization out in our totals. So let's do that now. Now you'll notice the prime factorization tree there. Now each of your trees, our trees could look different, but our totals need to be the same. So as we're doing the prime factorization for 24, it should be 2 to the third times 3. And the prime factorization for 30 should be 2 times 3 times 5. Now, since we are looking for the least common multiple, This phrase in number 6 is what you will be saying over and over to yourself to help you determine what to do from this point. You're going to multiply the highest power of all the factors that appear. The highest power of all the factors. So in my least common multiple for 24 and 30, I'm going to take 2 to the 3rd power times 3 times 5. That is each of the factors to the highest power. When I multiply these out, this is going to be 120. 2 to the 3rd is 8. Then I would like to do 8 times 5, which is 40. 40 times 3 is 120. So we're going to find the least common multiple of the numbers using prime factorization. I'd like for you to do A now. Refer to the example that we just did. Remember, do your factor trees. Then list your prime factorization. Then you're going to do each factor to the highest power. I'm going to pause it and come back and check your work. Now, as you can see, we did the prime factorization trees. Again, your trees could be different. Notice your totals to be the same. 36 is equal to 2 squared times 3 squared. 72 is equal to 2 cubed times 3 squared. We're going to take each factor to the highest power. So I'm going to have 2 cubed, or 2 to the 3rd, times 3 squared. 2 cubed is 8. 8 times 9 is 72. So the least common multiple of 36 and 72 is 72. So you'll notice the prime factorization. 20 is 2 to the 2nd times 5. 22 is 2 times 11. And 55 is 5 times 11. We took each factor to the highest power, which would be 2 to the 2nd times 5 times 11, and that's going to equal 220. So the least common multiple of 20, 22, and 55 is 220. Now, in this problem, you're going to find the GCF and the least common multiple using prime factorization. So the first thing you're going to make is what class? Factor trees. Then you're going to do your prime factorization. Then you're going to find the greatest common multiple. It has to be, greatest common factor. It has to be a factor in each one. And then the least common multiple. I'm going to pause the video, come back and let you check your work. So as we did our factor trees, then we do our prime factorization. Then to find the least common multiple, we take each factor to the highest power, which was 2 to the 2nd times 3 times 5 times 7. When you multiply that out, you get 420. Greatest common factor would be 2 to the 2nd. That is what each 28 and 60 have in common, was 2 to the 2nd. 2 to the 2nd is 4. So their greatest common factor is 4. Now I'm going to pause this. You can do B by using the previous examples to help you out. Okay, so our greatest common factor, once you check the factorizations of these, is 1. The least common multiple is going to be 9,360. One of the important tools of getting the right answer is going back, checking your trees for your prime factorization, and then checking your work. Now, with this concept, you will have word problems that you will apply this to. Number 9, Joe's watch beeps every 40 minutes. Sarah's watch beeps every 50 minutes. If both watches just beeped, when will they both beep again at the same time? we are going to do the least common multiple for each one. Go ahead and do your trees. Come back and check your work. So you'll notice the least common multiple is 200 minutes. We took each factor from 40 and 50 to the highest power to find the multiple of it. On our next word problem, I'll come back to it. 3 tour buses leave the visitor center at 9 a.m. Bus A returns to the visitor center every 60 minutes, Bus B returns every 40 minutes, and Bus C returns every 75 minutes. What is the next time the buses will all return to the visitor center? On this one, we did the least common multiple of 60, 40, and 75, which equaled to be 600 minutes. 600 minutes changed into hours would be 10 hours. So from 9 a.m. plus 10 hours later is 7 p.m. So the next time the buses will return to the visitor center is at 7